Okay, this is chapter 2, The Essentials of Oceanography, and it's plate tectonics and the ocean floor. This is the second slide. It says a lot of evidence supports this plate tectonics theory, and the plate tectonics models describe features and the processes on the Earth. Plate tectonic science has applications for Earth science studies, and the configuration of the land and the ocean has changed in the past, and it will continue to change into the future. Slide 3, it says that Alfred Wegener first proposed back in 1912, and he called it continental drift. And he proposed this idea of Pangea, and it was one large continent that was there 200 million years ago. And then he also said that there was one large ocean, and it included the Tethys Sea. And he said that it was like this puzzle that was fitting into the countries that we see today. And this idea, it was agreed upon in the 1960s, and Sir Edward Bullard, he used computer models to fit all the countries, the land masses, and he was able to, oh, it is a puzzle, they fit. Then we have on slide 5 a map, slide 6 as well, and how they match the sequences of the rocks and the mountain change, like the Appalachian and the Rockies, that they can kind of match it because they have similar rock types and the ages of how old that rock is and the structures on the different continents. And it also shows you a map that it shows you that has similar animals because of the fossils, like South America and Africa. If you look at it, you can kind of match it, and it would fit, right? Slide 8 shows you another map of that. Slide number 9, in 1950, Wegener, he published a book called The Origins of the Continents and the Oceans, and he said that the land, the continents, they plowed through the ocean basin, and they said that was a lot of criticism for that, and they teased him and picked on him about that, made fun of him, and they said that there was this tidal gravitational attractions. It was too small to move the continents, the land. And he said that the way it was done, it really was against the laws of physics. But he believed that the continents were floating through the water to arrive where they are now. And they are being pushed and pulled from like water tides, that's pushing it. And his way for this land drift, it was against the laws of physics, but his hypothesis was right, but how it was done was wrong. Slide number 10. They said this bathymetric survey showed mountain-like features on the sea floor. And in 1855, it was first published, this chart with underwater mountains, and that was published from the U.S. Navy that helped the ships. Slide number 11 says that the sea floor studies from World War II, they used sonar, which was, it had like waves, electrical waves that would kind of bounce back. And so they could kind of map it. And so they discovered these mid-ocean ridges. And the new technology has helped study this Earth magnetic field. Slide number 12. The Earth's magnetic field and paleomagnetism. And Earth has a magnetic polarity, north and south polarities. And it's been recorded in the rocks. And the paleomagnetism, it studies the Earth's ancient magnetic field, and that interprets where the rocks first formed. The magnetic dip are parts of these rocks, like basalt, is really hard, and it aligns with the Earth's magnetic field. It has a dip or a dip angle or this inclination. And so the angles made this horizontal by the Earth's magnetic field lines. And this angle varies at different points on the Earth's surface. And positive numbers or values of this inclination show that this magnetic field of the Earth is pointing downward inside the Earth. Slide 13 shows you some maps of that. Slide 14 also and some charts. On slide 15, it says that there's apparent polar wandering. So where the North Pole seems like it's changed over time, and there's this magnetic dip data. Slide 16 shows how the seafloor spreads, and it's one of the plate tectonic processes. So it has mid-ocean ridge, and it spreads to the center, and then it has the subduction zones where there's oceanic trench side of the Earth's crust destruction, and it can make these trenches, and it has this picture. So slide 17 says that Harry Hess, he was a World War II Navy captain, and he also studied rocks. Depth recordings show that the sea floor, the different features of it, and there's a history of the ocean basins, which is the sea floor spreading, and also the top of the Earth, the mantle convection cells as a driving mechanism. The expanding Earth hypothesis was debunked, and it says no, that's not right. And so while the sea floor is spreading in some places, they're kind of questioning that. Slide 18, it shows some sea floor spreading, the evidence of that. Slide 19, it shows all the different colors. It shows how old it is, and where they were able to detect that from all the different machines that they have. And then on slide number 20, as the sediments become more deeply buried, the compaction reduces the porosity that is porous, where it has like different holes and pores and liquid can get in there, and it causes an increase in this bulk thermal conductivity. So while the heat flow stays constant with the depth, the thermal gradient is not necessarily linear. So heat flow is heat from the Earth's interior, and it's released to the surface high at mid-ocean ridges and low at those subduction zones where it kind of pushes it down. Slide 21 shows you where most of the large earthquakes happen in these subduction zones, and earthquake activity mirrors this tectonic plate boundaries, where they have that boundaries. And the subduction zones that are active and the convergent, they're kind of getting closer margins. 22 gives you the names of all those plates. And on slide 23, it tells you the different types of those boundaries where it'll spread out, or they're coming together and one goes underneath, or they do this, they transform. 24 gives you a chart. 25, it tells you, it's an introduction of the plates move apart, and then the mid-ocean ridge and new ocean floor is created. And then they have shallow focus earthquakes, and how the intensity is measured with seismic movement. 26, it shows you a divergent plate boundary. 27 shows a divergent boundary and how it kind of spreads apart, and what it looks like, a rift valley. And so it's like this because it's broken apart. and the generation of the divergent boundary, and it says where that mid ocean ridge, where this is going apart, but then it's got a ridge there, and how it pushes apart. And shows you another picture of the formation of the Rift Valley. That's 29. 30, the same. 31, same. 32, the types of spreading centers. And it's showing you that this is the mid-Atlantic Ocean ridge. And it shows you a picture of that. Same thing on 33. 34, it says the plates move toward each other and the ocean crust is destroyed. It has a trench and it has a volcanic arc and deep focus earthquakes and great forces are involved, and then there are mineral structure changes that are associated with it. And then it has different pictures on 35, 36 as well. It says that the ocean plate is subducted, and then they have continental arcs are generated, and then there's explosive volcanic eruptions. Ocean to ocean convergence, and a denser plate is subducted. And then it talks about these deep trenches are generated and volcanic island arcs, which is like Japan or I think the Philippines, like this, Philippines, and Aleutian, which is in Alaska. It's Alaska and Africa, right? Kind of close together. 38, it's the types of convergent boundaries. And then the transform boundary features, and it says that it's perpendicular, so perpendicular this or perpendicular this, or you know what perpendicular is, to the mid-ocean ridge, and it allows the mid-ocean ridge to move apart at different rates, and they have shallow but strong earthquakes. 30, so 40, and it shows you an oceanic transform fault, and it's showing you one where there's one in like in the ocean and there's one on land, and they show that the one in the California, and these faults are in between mid ocean ridge segments. So it shows you that picture. 41 shows you another picture on the west coast. 42, it shows you the mantle plumes, which is on the earth, and the plumes and the hot spots for volcano, where that is, and how they move as well. And now it's going to show you all, the world where there's the hot spots on the plates. And then the plate tectonics and the intra plate features. They have sea mounts or mountains. They're rounded. They have tabletops or they have flattened ones. They have subsets of flanks of mid-ridge, and then they have wave, where you have wave erosion, and it flattens out the seamount. Can't get it out today. All right, 45, and it gives you the description about reefs and atolls, and the fringing ones, it says that they develop on the margin of the landmass, so where there's this buildup of the reef materials and it attaches to an island, and they're on the island, so they call it a fringing reef. And then the barrier reefs, and it separates from the landmass, and it has water, so it's a lagoon, so it's like a lake or a pool. And it says that as the plate sinks, then this reef material builds up, as the sea level rises, and then it leaves the island it's less exposed, and the area between the island and the reef, and it's kind of a protection. And atolls are reefs that continue to grow after the volcanoes are submerged. So here we have a volcano, and then it goes underwater, and then it has these reefs that build up right here at the coral. 46, and it shows you pictures of what they just described. Okay, so on slide 46 again, it shows you, it gave you the definition of these reefs, and then it's showing you pictures of what they look like. So that's 46. And then 47, the plate tectonic theory shows that Australia, so Australia, this is the sign, or Australia, it's moved north 7 centimeters every year, starting since the Cenozoic period, which I don't know when that is. And it's saying that the reef that's around it, so here is Australia, and so the reef around it is showing that this movement with the youngest part of the reef is in the south, and the oldest part of this reef is in the north. So here is our globe, and here's the Antarctica, and here's Australia, and then the reef around it, and it's moving this way. And so it's saying that this reef on the north is the oldest. So they're the longest, and it keeps moving northward. That's 47. 48 is giving you the definition of what these are, like paleogeography studies ancient continents. And the continent accretion is the material that's added to these edges of the continents through this motion of movement. And Pangea is one landmass. It didn't have different or separate countries, and it was formed 540 million to 300 million years ago. That's pretty cool. And number 49 is saying 100 million years ago, there's this one country, Pangea, and then it separated. So the North and the South American rifted, so it moved or separated from Europe and Africa. And then this new ocean forms, and they called it the Atlantic Ocean. Then 120 million years ago, South America and Africa, they are separate clearly. They're far enough apart. And then 45 million years ago, India, however you want to sign it, India starts this Asia collision. So here's India, and we know the shape of it, and this has all got mountains on it, and it says it's like it just collided with this other land, because you can see the push, and with that push that caused those mountains to form. They said that Australia now is moving north, right? So here's the Antarctica, and it's moving northward. So it's going to probably hit that as well eventually. And then number 50, it shows you all the different name tectonic plates and where they are and their boundaries. 51, it's saying that this is going to be the world map in 50 million years in the future. That's they're thinking this is what it's going to look like. And 52, it is saying that some is caused by the movement of terrains. And this is fragments of this crustal material that's broken off from one plate, and then it's gone accreted, it's attached to another one. And these terrains, they have distinct separate history, and they differ from the surrounding area. So that's why they know that it's separate, and it's kind of going back together, and it's attaching all these different ones. And it has a picture. 54, it's a chart, and it shows you the different ages. And then that is the end of chapter 2 of plate tectonics and the ocean floor. If you need more clarification, let me know.